So we're going to talk about translations. So we have a diagram and we're going to translate the diagram. And the translations will be the same. Now, as a parabola shift. I don't know, I'll look. All right, so what do I mean by that? When we have a parabola, we have y equals a times x minus h, that quantity squared, plus k. The h represents our horizontal shift, and our k represents our vertical shift. All right, so when we have something cubed, when we have y equals x cubed, anybody remember what that looks like? The disco dancer, you got it. And then if we have y equals negative x cubed, yeah, we got that disco dancer. So I said the translations are going to be for all of these the same as a parabola. So here we're going to have y is equal to a times x minus h cubed this time plus k. Again, h represents the horizontal shift. K represents the vertical shift. H comma K is the turning point of the disco dancer. All right, so can we do a shift one? Okay, so I want us to sketch y equals the quantity of x minus 1 cubed. So this, if we were talking about the parent function, it would be our traditional disco dancer x cubed, right? But now I'm shifting this disco dancer where? 1 unit to the right. I'm shifting 1 unit to the right. So now here's my turning point. So remember, the turning point is hk. We know our k is 0. So our turning point is 1, 0. Doesn't that also count as our x-intercept? Will there be a y-intercept? Yes. Let's talk about the y-intercept. So we're going to have y equals 0 minus 1 cubed plus 0. We don't need that. So we're going to have y is equal to negative 1 cubed, which is negative 1. So the y-intercept is the point 0, comma, negative 1. All right, so now we know the 1, 0 is our turning point. So that's sort of where, I'm so bad at the disco dancer. But, oh no. Go back. Oh. There's only, what do you mean? Something like that.
If I mess it up.
No, like I messed it up. Like this is not the perfect disco dancer. As long as I know that you're turning at the turning point, you're good.
Turning point's a vertex, right? Or HK?
It's HK, yeah. You just need to know, you just say wide, like wider or more narrow. All right, you guys try one of these on your own. No, we're not done. Then I got to show you a couple more things. So you guys try this one. So you all are sketching this one.
I don't know yet. You're like, I know. Are you talking about the graph one? You don't say yet. This is question. It's not hard. No. Do like a rough sketch here.
All right, let's go through this. So we know this is a disco dancer because it's raised to the third power, Aditya. Chris, turn around. All right, so we know it's a disco dancer because it's raised to the third power. We also know that it's the reverse disco dancer because A is negative. So that means we're going from quadrant 1 to quadrant 2 to quadrant 4, right? So we're sort of like an inverted disco dancer. We also know that we're shifting. We're shifting 2 units to the right for our turning point and 1 unit up. We know all of that. So I'm going to start off with my turning point. Our turning point's always h comma k, so our turning point is going to be positive 2, 1. That's our turning point. Okay. Since we know the A is negative, so we're quadrants 2 and starting 2, ending 4, are we going to have x and y intercepts? Absolutely. So let's find those x and y intercept. So x-intercept, we are saying 0 equals the negation of x minus 2 cubed plus 1. I'm going to move that 1 over, so we have negative 1 equals the negation of x minus 2 cubed. I'm going to divide by negative 1. So I have 1 equals x minus 2 cubed. I'm going to now take the cubed root of both sides. Cubed root of 1 is just 1. So now we have 1 equals x minus 2, so x will equal 3. So our x-intercept is the point 3, 0. So we'll plot that. And now let's talk about our y-intercept. All right, our y-intercept is going to be y equals the negation of 0 minus 2 cubed plus 1. So then we're going to have the negation of negative 8 plus 1, which is 8 plus 1, so that is 9. So our y-intercept is the point 0, 9. All right, so I usually start off with my turning point to like make the disco dancer curve. Do you guys see what I mean by that? So I made my disco dancer curve. I'm going through my x-intercept and then up through my y-intercept. This is just a rough sketch. It's not going to be great. All right. So Next one, let's talk about applying absolute value, which we've already done. We did this before. Y equals the absolute value of x squared minus 1. It's not a V. Clearly, we do need to do this again. All right, so this is not a V. How do I know this is not a V? Because the x squared, good, Aditya, it's going to end up looking like a W. So if you all remember, what this is saying is sketch the parabola, then take the absolute value of it, which means y can't be negative. So anything under the x-axis needs to be turned positive. Right? That's what that means. So sketch your parabola. Anything that ends up underneath the x-axis needs to be turned positive because y has to be positive because it equals the absolute value. So let's go ahead and do our sketch here. All right, so this is really x minus 0 squared minus 1. Do we all agree? So I'm not shifting left or right at all, but I am shifting down 1. Yeah.
Isn't it x minus 1 in the absolute value, and then on the outer side it plus 0?
Oh, no, so I'm talking about the parabola inside if we're doing x minus h squared plus k. So I just changed that format. Do you see what I just did? All right, so now I know I'm not moving left or right. I am moving down 0. I'm sorry, down 1. So we know our y-intercept is 0, negative 1. There will be x-intercepts. So let's go find our x-intercepts. So our x-intercept is going to be 0 equals x squared minus 1. Add the 1 over. Our x-intercepts will equal plus minus 1. So we're at 1, 0 and negative 1, 0. All right, so there's a sort of rough sketch of our parabola. Now we take the absolute value of this parabola. What does that mean? That means y has to be positive. Well, where is y negative? Y is negative. Everything underneath the x-axis means y is negative. Do we all agree with that? So it's not that it disappears. What happens when you take the absolute value of a negative 1? It becomes positive 1. So when I take the absolute value of this point, 0, negative 1, it becomes 0, positive 1. It becomes 0, positive 1. So that's this point up here. So now I'm going to erase everything underneath the x-axis. And what happens? I hit the negative 1, then I can't go through. Sort of blocking, right? Because we have to stay positive. So what happens? We bounce back up. We hit the 0, 1. And then we come back down. But again, I can't go through because of the absolute value. Everything has to be positive. So what happens? It bounces back up. Remember, we had done these. All right. Now let me show you something. After this one, I just have to show you probably one more problem, and then we're done. After this one more. So what this is saying, Arish, is this a V? No, Dylan. This is not a V. Why is it not a V? David, tell Dylan. Why is this not a V?
Because it's x squared.
Because it's x squared, Dylan. You're not paying attention to David. All right, because it's x squared, it's not a V. What is this saying? This is saying a couple of things, actually. This is saying graph your parabola, take the absolute value of the parabola. But then there's a negation in the front. So then they're saying, not only do you graph this parabola, take the absolute value of this parabola, then the negation is sort of a reflection. Then reflect that parabola. There's, we'll see. Yeah, there should be problems like this on the review. There's no shifting problems?
So that means it shouldn't be on the test.
Maybe I attached the wrong review. I'll check. Okay, so guys, we're first sketching the parabola. So the parabola, we're not shifting left or right at all, but we are shifting up 1. All right, will there be an x-intercept? No. It's going up. There's no x-intercept. It's going up. You're graphing just what's in the absolute value lines, right? So now, when it says take the absolute value of this, is anything y? Is there any negative y's here? No, isn't this already the absolute value of it? So we're good. So now we go outside, and it says the negation of this. The negation of it is reflecting over the x-axis. So if I'm going to take this image and I'm going to reflect it over the x-axis, that turning point is no longer 0, 1. It's now 0, -1, and now I'm turning down. That is our final graph. No, all we need is the final one. You can't leave the original, no. Because of the negative in front of it. So like I sort of, you can cross out the top one. If you like the process, you can cross out the top one and like, or just circle the bottom one. I don't look at the work that's crossed out yet. Technically, it doesn't exist if it's crossed out. Okay. Let's talk about translations now. So this is technically the only thing I haven't spelled out for you before. All right, so these coordinates do matter. So we're at -2, 0, 0, 3, and 4, 0. And then it should look something like, I want it to look something like that. Actually, I don't want it to look something. I want it to be a little bit straighter here. Oh. There we go. So this is our f of x. This is just our random function. It's nothing specific. It's just a random function. And now I want us to translate it all different ways. The first way I want us to translate it is f of x minus 2. We're following the same translations that we do for the parabola. We're following the same translations we do for the parabola. So what does that mean? All right, whatever's with the x is our horizontal shift. Whatever's outside of the x is a vertical shift, right? So this is saying take all these points and shift it 2 units to the right. We're going to shift it 2 units to the right. So I'm going to take this, and now we're here. I'm shifting all my points 2 units to the right.
Would you just move the vertex?
You move all the points.
Yeah, but if you move the vertex, you move all the plane space. All the energy. Doesn't matter. And also figure out everything.
All right, we're doing more shifts on the same one. Yep, we're still going off of the original. All right, remember, we're following shame shifting as the parabola. So now this time, my plus one's on the outside, not in the parentheses. That means I'm taking my original and shifting everything up 1. Everything up 1. So you go back to the original, we're shifting everything up 1. These are just rough estimate sketches. All right, now what am I doing? Now I'm saying the negation of f of x. Well, what did I say the negation is? Reflecting it over x-axis. So basically all I'm doing is taking each of these points and reflecting it. So instead of 0, 1, 2, 3, we're 0, -3. What was the other one? We had, oh no, it wasn't 0, negative, is 0, 2, sorry. So 0, -2. And then we were at 0, 1. Oh, did I shift the wrong one before? I think I had shifted, did I shift or did I shift the right one? We're okay? Okay. So it was 3. So it was 0, 3 originally? Okay, sorry. So we're 0, -3. I was right the first time. Okay, and then we are at, I have to go back to the original. That x-intercept stays. Both x-intercepts stay. 1, 2, 3, 4. 1, 2. There we go. So then this looks something like that. All right, and the last one for shifting. All right, yes, Claire. The negation of f of x, is this the same as the inverse? F of x, so you're saying, do you mean the inverse, f of oh, f of -x, yes, yes, because you're reflecting it over the x-axis, so that's what's happening there. All right, so f of x, the absolute value is make all y's positive. So you go back to your original f of x, and what does that mean? Where are we negative? We're negative here, and we're negative here, right? So what does that look like? No, we don't stop. We make them. You bounce back up, exactly. So what were my points? I don't even remember. What was the top point? 0, was it 0, 3? 1, 2, 3. And then the x-intercept was, I don't remember, what was it? -2, 0. And 1, 2, 3, 4, 0. All right, so what does this look like? It looks like we got to reflect it up, come down, bounce back up. That's it. That's everything I needed to show you. Aditya? Yeah, if the negation of the function is the same as just negating the x, yes. Is that what you're asking? Because that's what Claire asked. Yes, David.
So absolute value is basically take the parts that go down.
Ariana? Like there? Or like the first problem in the like altogether?
Added 5 subscribers to the account. Miss Abdullah.
Yeah.